So let us just go through one more example of voting systems so that we fix the ideas, since this is such an abstract topic, right? So imagine that you have got a fixed monetary budget that can only go to one of the three causes or issues, right? It can either be allocated to health, security, or education. And this is going to be decided based on the preferences of 12 voters, each of whom is going to submit their full ranking of the different alternatives or options that are available, right? So you've got three type L voters, right? So when we say numbers three, it means that there are three of such voters who think that health should have the most priority, and after that security, and after that education. You have also got type M voters, and there are four of them who think that the topmost priority should be education, the second priority should be health, and then the third priority should be security. And finally, you have also got five type R voters who think that security should have the most priority, then education, then health, right? So you have got basically different voters. You may think that these are voters of different kind of like political viewpoints, and they have different priorities in terms of like what should be the topmost allocation, right? However, remember that at the end of the day, we still have to decide that the budget has to go to only one of the three causes. So the question is, should the budget be allocated to health, security, or education? So how do we kind of like go about figuring out? Since each of these voters have submitted their full ranking of alternatives, we can see for some of the different systems that are actually operational in the world, what would be the answer that would kind of get, right? So the first system is plurality voting. And we have talked about this system before as well, right? So what's going to happen here is that each of the voters have submitted, and only their topmost preference is going to be considered. And on the basis of that, we are going to decide on what is going to be done, right? So every voter's second and third choice is ignored. Basically, you only get to kind of like, if you're a voter, you only get to say what is your topmost choice, and on the basis of that, a decision has to be taken, right? So if you look at it, three of the voters have health as their topmost choice. Four of the voters have education, and five of the voters have security. So since security has the highest number of votes, it's actually going to be the case that the budget is going to be allocated to security. Now, the problem with this method is the following, that if you think about the comparison between security and, for example, health, you would notice that seven of the people would have preferred health over security, and only five would have preferred security over health. So even though the plurality voting system says that security would win, however, the majority of the people actually kind of like preferred health over security. However, this was not taken into account because in the plurality voting system, only the top choice actually matters in terms of the ranking that is submitted. Okay. Now, the second ranking system is what is known as instant runoff. And this is actually quite similar to how the French voting election actually happens. So what happens in this case is that you add up each topic's first place rankings. And if any topic has more than 50% of the vote based on that count, then that topic wins. However, if no topic has more than 50% of the vote based on first place rankings, then you eliminate the lowest ranked topic and then again rerun the election between the topics that remain, right? So let's see what happens if we kind of like follow up on that here. So we have got that you have got three has health as the top, four has education, and five has security. So the total number of voters is 12. So there are no issues that have received more than six votes. So we do not yet meet that 50% criteria. So in that case, we have to eliminate the lowest first rank position, right? So what is the lowest? That is health, right? Because health had got only three votes. So if education and security are the only ones remaining, and then again, we ask the voters basically on the basis of this submission, we can actually do it themselves. So now suppose only security and education remain, how many are going to have security as their top? So the type L voters are going to have security as their top, right? And also the type R, right? So out of the 12 now, eight of them are going to have security as their top choice, and only four of them are going to have education as their top choice, right? So this 50% criteria is now met, and hence, therefore, now security is going to win, right? So this is how the instant runoff system works. Now, the third system is known as the couplets method. And here the idea is the following, that we are going to select as the winner the issue that wins the most hypothetical 2% contest against other candidates, right? So how does that work? So for example, let's first consider who would have won the health versus security issue, right? And here it's important to also count the number of people who are voting in favor, right? So if you have health versus security, The type L voters are going to vote for health. The type M voters are also going to vote for health, but type R voters are going to vote for security, right? As we see from these preferences. So if it was a contest between health and security, 7 times health would have won, right? And security would have defeated health 5 times. So we note that down here that health beats security 7 times and security beats health 5 times. What about health and education? So if we again go back to the preference, the type L voters are going to vote over health for health over education, but the other 9 ones are going to vote for education over health, so that health actually defeats education 3 times, right? But secure education beats health 9 times. What about security and education? So again, if we go back, we observe that type L would vote for security over education, type R would vote for security over education. So 8 votes for security over education, but the type M voters are going to vote for education over security, right? So 4 of them are going to be in favor of education over security. So again, we note this down, right? So we have now all the information that is required. So in terms of head-to-head clashes, how many times does health win overall? So health wins basically 7 plus 3, 10 times. How many times does security win overall? So it wins 5 times here and 8 times here, so total 13 times. And how many times does education win? So education wins 9 times here and 4 times here. So therefore, health has a total of 10 wins, security has a total of 13 wins, and education has a total of 13 wins, right? So basically the final result is that security and education tied, and you need basically a tiebreaker, right? So one thing that we notice is that the Copland's method may not necessarily produce a unique winner, right? But the advantage is that if it does produce a single unique winner, then this winner would actually end up beating every other candidate in a head-to-head race. This is something that one can show, but this is outside the scope of our discussion at this point. So that, I hope, gives you a bit more idea of like how to work around with this different voting systems that you see here.